This video was produced by
Good morning, everybody. Appreciate those of you making it here on time. I recall one of my elementary school teachers saying, "We're all in our places with bright shining faces." So hope everyone had a good night last night, a good day yesterday. We appreciate you being here this morning. I think we have a real good session set up today for you, and I'm just going to give you a little background on it, as hopefully you're able to pick up the bios here from folks that make up the panel. And I want to let you know that we think that we have a program that you're really going to like today. A couple thoughts I would say just to maybe frame it. Having been through yesterday and had some great sessions yesterday, I observed when the opening speaker talked about, second generation pioneers, if you will. And I think that was a pretty nice way to describe, some of the work there is to do in Virginia. You probably heard the term, a stuck state mentioned a time or two yesterday, and I think that's in reference to a state that doesn't, really have any utility scale generation. And we did spend a lot of time on that and talked about some of the fixes there. But today we're gonna shift gear a little bit there. What we're gonna do is we're gonna talk a little bit more about things like community, probably phrases like "do it yourself" come to mind, outreach. Cooperation, entrepreneurship. I think if you listen closely, our focus on small and community scale today, I think can really help to provide you with some ideas and hope for success stories. We have examples of them here today, real success stories in Virginia and in some of the areas around. Even I think it would be really good to learn about. So. To the extent that we see some challenges in Virginia, I hope that and think that this morning the speakers will really help to open your eyes for folks that have just refused to take no for an answer, get out there and they make it happen. So with that, hopefully we'll be able to answer a lot of questions that you have. The panel discussed the desire to have a good chunk of time at the end of the day for questions and answers. So we just like to look at it like we're a panel here to help you. And so if you hold your questions till the end, we will preserve a nice piece of time at the end to have Q&A. So with that, I will step aside and we'll bring our first presenter up, Bob Zickefoose. And welcome, Bob.
I'm going to speak loudly enough. I'm kind of used to doing that. I hope it'll work.
Because they're going to record it.
All right. Well, we can do that if you want. Okay. All right. Got to see what I'm talking about here. We'll see if we can get this to work. My name is Bob Zickefoose. I teach engineering at Blue Ridge Community College. And for those of you that don't know, that's just down the road, 12 miles or so between 11 and 81, right sandwiched between the two. And this is a small wind part of the program, but what I'm going to be talking about is very, very small wind here. This is a little bit different than you might have expected. But talk about the design fabrication of an ultra-low cost DC wind generator using recycled parts. Well, the whole point here is to kind of make something out of nothing, or something out of parts that could be donated, or parts that would be readily available for very little. Let's see if this will work. The clicker doesn't work. Let's see if we can make it go. All right, we'll use Plan B. All right, Blue Ridge Community College has a very active Students in Free Enterprise. We call it SIFE. They've competed in many different competitions nationally and done very well, won some national recognition. And over the 3 or 4 years that they have been very active, they have developed a connection in Haiti, the island of Haiti, helping people. They were actually there, our students were actually there when the earthquake occurred. We're outside of a school when the earthquake occurred. So they have about 3 or 4 different places that they're working on the island of Haiti to help these folks, specifically not yet with electricity, but more just in support in building and that type of thing. So we recently at Blue Ridge started what we call a Career Study Certificate program in alternative energy. And that's just a 9-credit career study course where a person's awarded a certificate. And the idea there would be to get folks, and a lot of these folks are not young people, they're working somewhere or have lost jobs somewhere. But the idea would be to get them familiar with the various types of alternative energies so they could be potentially a good employee for somebody who's starting up a green business of the installation, let's say, of maybe residential solar or residential wind. We wanted to get them aware of the technologies so they would potentially be a useful employee. So as part of a design project for that career study certificate and to support this Haiti connection, we decided to build a very small DC wind generator that could be used just as a battery charger to supply some folks, potentially on the island of Haiti or potentially anywhere where there's a wind resource, that are completely off the grid. These would be folks that are completely off the grid. Haiti has a semblance of a grid in some of the more populated areas, but it's very unreliable. The vast majority of the people there don't have electricity from the grid. About 1/3 of the world still has no electricity from the grid, probably never will. They'll get it from alternative sources. Okay, here are our goals. We wanted to use standard structural shapes, and you'll see this in a second, to act as a mount for recycled automotive components. Why did we choose automotive components? Well, there are millions of them out there. There's millions of recycled parts, for one. They're standard. You can specify a particular model of a particular year or many years and get the same parts. You know what you're getting. And for the most part, they're very strong. You know, they're designed for automotive use, so they can be plenty strong for what we wanted to use them for. We used automotive spindles and drums as the rotor and yaw bearings, the rotor for the blade and the yaw bearing so the machine can track the wind. We mounted the rotor blade directly to an automotive wheel. You'll see this. We used a common automotive alternator as a DC generator. Alternators are a dime a dozen. I mean, they're scrapped all over the place. They're so cheap now that I see alternator rebuild shops kind of going out of business. You know, you don't see as many as you used to see. So there's our DC source. We use a timing belt to drive the alternator. We got to speed it up somehow. We can't run it directly off the rotor, so we have to speed it up. We use a timing belt to get a speed increase, and I'll show you. We fabricated, or we're going to fabricate a guide tower using just galvanized structural pipe, and then we wanted to use recycled parts wherever we could. And the idea here was to eventually get folks to donate these parts so the material cost of this unit would be nothing, in effect. And we have CNC capability to do the basic machining that we need at Blue Ridge, or it'd be very easy to do. It's just drilling holes for the most part. I'll show you some pictures. This is a wheel, it's actually off of a VW Jetta, a front wheel, back wheel, doesn't matter, the wheel. And you see the alternator mounted to it there, and that's the speed increase that we use, about a 7-to-1. You know, we need to get that alternator over 2,000 RPM, 2,500 or so, before it'll put out any useful electricity. And we can go on. Okay. And there you see a side view of it. That's the belt drive from the alternator to the large wheel. And what we did is, you know, when you start designing stuff like this, you got a lot of options in terms of what type of drive you're going to use. You could use gears. That would require some type of lubrication. You could use a friction drive. There's a lot of initial resistance to turning with a friction drive. You could use a flat belt, you could use a V-belt. There's a fair amount of resistance there too. We chose the timing belt because We use a cogged pulley on the alternator, but we don't need to use a cogged pulley on the wheel because it isn't going to slip on the large pulley. It would only tend to slip on the alternator itself. The whole point is this thing turns very easily, so we can just use the torque supplied by 12, 15 mile an hour wind to get this thing started to turn, and then it will, once it starts to turn, it will pick up speed pretty quickly. And I didn't know if I show it, but we need to control the alternators on and off. We can't just keep it hooked to the battery all the time, or the field in the alternator would run down the battery. This would be like leaving your ignition switch on in your car. Eventually, that would run your battery down. Take a long time, but it would run your battery down just by powering the field of the alternator. So we have a centrifugal switch mounted on the back of that alternator that once the alternator is up to a certain amount of speed, that's what will turn on and off the juice from the alternator to the battery. There's that centrifugal switch. You see it mounted on the back there, mounted right to the shaft of the alternator itself. And what we did to mount all this, we just used standard structural shapes. Both all of the units are mounted on 2 pieces of channel, very regularly obtained common channel, 6 by 6 by 3/8. We got that actually donated to us too. And then we just drill holes in the channel to mount the components. And the 2 spindles, and you can't see it, we'll look at a spindle in a minute, but we chose the spindles from the vehicles such that they are flat, and they just mount directly with 4 bolts. So, you know, you got a variety of different cars out there, but if you start looking around and seeing how they're put together, you find certain varieties that will mount much easier and without fabrication to the particular car part itself. Okay, one more. Nope, go back one, please. All right, there you see a view of the back, and so what we have down at the bottom here, that's a brake drum and mounted to a piece of channel with the tower below, and then there's another piece of channel that mounts where the rotor will go and mounts the alternator, and that's that standard 6 by 6 by 3/8 channel that I was talking about, and they just have holes drilled in them. The 2 U-bolts you see there are where a tail vane will go in, because it'll be an upwind unit with a tail vane. Tail vane will just stick out the back, and in that brake drum underneath will be housed the slip rings. You know, whenever you're generating power with a unit and that unit is free to turn around, you somehow have to get a stationary output for the wires to come down the tower, or you will twist off the wire. No, I know years ago they said that, well, statistically, you ought to be able to just put a very flexible extension cord right down the center of the yaw spindle, and statistically, over time, it should turn about the same amounts right and left, and it should never turn itself off. That doesn't work. I've tried it. It turns itself off. So we need slip rings, and that's what we will put in. And slip rings, again, there's a moving component that's charged and then a stationary component, and you slip them across. Next time you go on your next Ferris wheel ride or next time at the fair, look underneath and you'll see slip rings because they're getting power to that so it can move. Okay? Tail vane. Tail vane's just a recycled swing set tube. All right, tail vane tube, I should say. That'll have a piece of aluminum on the end of it to actually act as a tail vane. But all that is a steel, very light, very thin, recycled swing set tube. They're thrown away all the time. Okay. Next, please. All right, there you get a view of the how the tower connects to, again, that channel. There's the 6 by 6 by 3/8 channel tower connecting to it. That's a 2.5-inch structural pipe. Schedule 40 pipe is all that tower is. That'll be 15 feet tall, and it'll be guyed with 3 wires. That's probably the least expensive tower we could come up with. Just a simple guyed, single tube structural pipe. And the U-bolts that hold it, those U-bolts are the U-bolts that hold leaf springs to car axles. Okay, so again, we're using everywhere we can. We're trying to use recycled parts as much as we possibly can. Next. All right, there is again a picture of the where the brake drum, where the slip rings will be housed. There'll be a a stationary part mounted to the bottom of the channel there, or the top of the channel, and then there'll be the moving part will actually be the brake drum that goes apart on the inside. There'll be two connections, a plus and a minus. We could actually, because just like a car, we could get by with one and just ground everything and have that the minus connection, but usually on a wind generator, that's not a very good idea, because when you do that, you are sending the minus through bearings. And it's never a good idea to send electricity through bearings, because it will pit them over time and deteriorate them. So you want to supply a separate path for that minus juice. Minus connection. One more. Okay. That's what the slip rings look like. Just be two. The part in the middle will be stationary, mounted to the bottom of the channel, and the wires you see going around, they will turn. They will turn with the unit completely as you see it there. So there again, pretty simple parts. That's just a piece of PVC pipe that'll act as an insulator inside the brake drum, and the wires are just laid into it. And those are standard plumbing components that you see for the other ones. They'll be spring loaded against the wires there that you see. And PVC insulators there, because you want to insulate that as it comes down. There is this connection will go straight to a battery. The idea would be there that as a battery is charged up, whoever wants to use it wherever they need it, they would take it, and then you'd put another battery on to charge it up. And they could measure that charge with a voltmeter if they wanted to. Well, the unit wasn't running. That would probably give them a good indication of the charge of the battery. Okay, one more. We're going to use a plastic 55-gallon drum as the cover, as the nacelle for the thing. Again, a recycled part that will probably withstand UV pretty well outside. And again, we don't want to get into any elaborate construction to be able to build the thing. One more. That's what the blade looks like. It's a simple two-bladed rotor, and there's a lot of reasons not to use two-bladed rotors. Three is obviously for a lot of reasons is the ideal situation, but whenever you start talking a three-bladed rotor, then your connections for the three blades become much more complex. This is simply made out of a 2 by 6 by 10-foot board. Okay, so you can make a rotor that works pretty well, and again, we're relying on the robustness of our components to withstand the negative of a two-bladed machine, which tends to yaw through a series of jerking motions. But that should be all right for this unit. It'll be built strong enough. And that's what the blade looks like at the end. It probably has about a 3-degree angle on the end, going up to a 12-degree on the root where it goes back. But it's very simple to fabricate. I fabricated this blade in about an hour with a draw knife, and have tested it, and it works pretty well. So again, we wanted to keep the minimal amount of effort in this and make it as cheap as possible. Excuse me? Yeah, it would be treated. Well, no, it would be coated with some kind. Yeah, at least. You'd have to protect it from the outside. That might be the end. Let's see if we got anything else here. That is the end. So that's what we plan to do, and we've got this probably about 80% constructed, and we're gonna test it at Blue Ridge, send it down to Haiti, see how she does, and if it works well and there's a need for more, we will potentially start going around using our SIFE people, our students in free enterprise, to get these parts donated to us. We'll specify what parts we need, and we'll start building multiple units. Well, that's what I want to talk about. Thank you. Thank you.
Thank you, Bob. Thank you. I must apologize. I think it probably would have been a good idea to have read your bio beforehand, and I didn't do that, so sorry about that. I will say this, though. Right as we walked up this morning, we were talking for a moment, and I just met Bob, and he lives close by, and he said he'd went home, and anyways, I asked him how he usually gets to work, and he says he bikes every day, 13 miles. And been doing it for how many years? So he's in shape. But no, that very much appreciate your ingenuity and sharing that with us. It was quite amazing. Well, with that, we'll move on. I'm going to go ahead and read bios just prior to the next two speakers. I think it'd probably be a good idea. So next up, we have Loren Pruskowski with Sustainable Energy Developments. And Mr. Loren Pruskowski is a founder of Sustainable Energy Developments Incorporated, where he currently supports the company as the Chief Financial Officer. Some of Loren's main responsibilities with SED include co-creating SED's vision, developing a corporate capital structure to realize SED's vision, assessing the viability of decentralized community wind projects, and communicating to project stakeholders, the technical, political, environmental, social, and economic issues associated with wind energy projects. Prior to the formation of SED, Loren worked at AWS Scientific, currently known as AWS True Power, an Albany-based meteorological and wind energy consulting firm. So, I think we'll get some really good insights from Loren as to things that that he's come to know about Virginia, and I think we have the benefit of knowing that he's worked in a lot of other states. Therefore, some of his observations I think are really grounded in experiences in other places, and look forward to hearing his comments.
Thanks, Don. So when I need to change, I'll just kind of point. Okay. Good morning. Thank you all for coming here. As you know, my name is Loren Pruskowski, and I'm with SED. Today I'm going to be talking a little bit about our company, SED, and how we define community wind. I'm also going to be talking about the different phases that a project goes through from conception to fruition. And then I'm going to give you a couple examples of projects that are either in the development phase or have been completely developed and constructed that we've worked on. And then I'm going to talk about characteristics that help support a community wind market in each state. And then I'm going to apply that to the Virginia market. A little bit about who we are. We're a community wind consulting and development company. We've been in existence for a little over 10 years. We recently celebrated our 10-year anniversary a couple months ago. It was something we're very proud of. We had a great time. We primarily work throughout the Northeast, although within the next year we hope to be doing work throughout the nation. We're an employee-owned company, and we've got about 50 projects that we've worked on from conception to fruition in the ground. So when I talk about community wind, I'm really talking about helping a community control their local energy supply using wind power. So there's a local ownership component, and there's also a component of local energy use. And the way that we look at community wind, we kind of put it into two different project types, and that's an on-site wind project and small wind farms. On-site wind projects are those projects that use a turbine to power a facility directly, thereby offsetting electricity that would otherwise be provided by a utility company. So this offsets retail valued power. And the size of these projects really depend on the load of the facility, how much energy it consumes, and the ease or access to capital by that facility owner. Sorry, back one more, yeah. And then small wind farms essentially the size of the turbines that are used in a small wind farm have to be a megawatt class machine. They have to be large in order to make these projects work. These projects are interconnected to the distribution system. It's not the high voltage lines that you see a utility scale wind farm connect to. Utility scale projects, they send power 50, hundreds of miles to the nearest load zone. For a small community wind farm, you're basically designing a project so that the community can use all the energy that's generated by a small wind farm, and you place the electrons on the distribution circuit, so then it feeds each facility within that distribution circuit. And these can be a couple megawatt size projects. Right now we're developing 3 different projects in New York State, small wind farms. And just so you know, that those compete on the wholesale power market. So on-site wind projects offset retail valued electricity, and wind farms compete at the wholesale power market. So I just wanted to give you a little understanding of the different phases that a project goes through from conception to fruition, so then we could apply some of this background to the Virginia market. The first phase, site prospecting, really exists when there's multiple projects within a region that could be harnessed. So you could be looking at, a county could be looking at all the different places that might support a small wind farm, or a municipality might be looking at a bunch of different locations that might be able to support on-site wind power projects. Essentially what you're doing in this phase is you're trying to identify the fatal flaws associated with a project. So you're looking at some sort of, you're trying to identify the wind speed at a site, comparing it to some sort of minimum wind speed threshold to make a project viable. You're looking at some of the social and political constraints that might be associated with a site, and you're looking at the ease to interconnect a project at that site. So once you finish up the site prospecting component of a project, you've identified one or several sites that you want to move forward with. At that point, you enter the feasibility phase. And the feasibility, really what you're trying to do is capture or identify all the cash inputs and outputs associated with the project. You're trying to make reasonable assumptions about how those inputs affect the project. So the end product is a pro forma, something that shows in year 1, 2, 3, 4, all the way down to 20, these are the costs associated with the project, and this is the revenue, this is what's left over. And if you are able to show a viable project or find a project owner that's willing to capture these economic benefits, then you move forward to the permitting and design phase, which is just what it sounds like. You're trying to gain every approval for a project, and at the same time you're designing a project. So you're looking at the civil, mechanical, and electrical design of each project. For larger projects and for smaller ones, the actual foundation and the design can change quite a bit from project to project. So once you have your design in place, you go and you try to get all your permits. You know, you need to get an interconnection agreement. You got to go in front of either a town or county board and gain approvals for building that project. And this phase can take quite a long time, and or it can go rather quickly. It depends on the level of community support. In order to make it through this phase, there needs to be a solid or at least a decent level of community support. And the way that we define that is there has to be someone that's willing to host a project and stand up for it and go and speak to their neighbors in support of this project. And there also has to be either the town or county has to have laws on the books or a means to be able to give you permits for this project. If there are no laws on the books, meaning there's no zoning ordinance pertaining to wind, this process can get very convoluted. So if you want to be able to effectively navigate through a project, when you're in the prospecting or feasibility phases, you really want to start engaging the the local planning board, the local zoning board, and tell them about your project. And you want to start cultivating support for a project, talking to your neighbors, getting their feedback, and integrating that into the actual siting of a project. Once you have all the permitting and design work done, you've got on all your approvals, that's usually when you're handed project financing. What I mean by that is you have construction financing, so you can buy all your equipment and you can then execute on the design. So the construction is really just taking the design and implementing it. The construction is the fun part of the project. It's really quite simple, to be honest. It usually only takes a couple weeks. For a smaller project, it can take a couple days. After construction, you commission a project and you're able to, at that moment in time, use the electricity that's generated from a turbine. And at that point, really you're just trying to maintain your equipment so that it has a long life. Some of the smaller wind turbines have been up for over 30 years, and if properly maintained, they will probably stay up another couple decades. The larger turbines are designed for a 20 or 30-year life cycle, and after that, you basically have the civil and electrical infrastructure in place so that you could change blades or nacelles, or you could basically put a new machine on top of the existing infrastructure. So you can get 2 generations of lifetime out of these projects. Okay, so now we're going to kind of talk a little bit about the different projects that we either have in development or have developed. I talked about small wind farms earlier and how we have a few projects in different phases. We have a project, they're all in New York. We have a project that's right now in the site prospecting phase, one in the feasibility phase, and one that's somewhere in the design and permitting phase. And when I'm talking about these small wind farms and how we interact with the community, essentially we're partnering with the community so that we can work with them and they could help us figure out where a project's going and how to structure it, meaning how many turbines there are and how to structure the ownership component so that they can maximize the revenue from this project going forward. If a community wants to gain ownership in a project, they need to be active in the development phase. They have to be part of the decision-making process. So oftentimes, there's many ways that they can be involved. They could have a steering committee, or in some other cases, they can form their own company or entity, development entity, and hire someone like us to manage the project for them. So essentially, we're co-creating this project with them. Everything that we do for these community wind projects have to be transparent. If you want a community behind the project, you got to share your ideas with the community, and then you have to be open to listen to their ideas, whether you like them or not. Really, the community can own this project, develop it through a variety of means. When we say community-owned project, there is an entity that's local that represents the community. It could be a group of landowners, it could be a municipality that develops and owns this project, but somehow there's a means to bring revenue and project decision to back to the community. Okay, thank you. Okay, so these are a few examples of on-site wind projects. Giecekowski's, this is an installation we did in upstate New York. This installation took about 9 months. That's very quick. The development process for this whole project took 9 months. There were laws on the books that allowed us to easily gain permits. The production from this turbine, which is a Birdie 10 kW, is about 10,000 kilowatts per year. That equates to a savings of about $1,300 to $1,500 a year in year one. The turbine itself stands on a 120-foot tower. Blades are roughly 11 feet long. And the Giecekowskis are very happy with this installation. It was a really easy installation to put up, and this is probably one of the smoothest projects we've ever worked on for small wind. For kind of medium-scale on-site wind, this is by far the easiest and most enjoyable project we've ever worked on. This story is a wonderful one. This is in Maine. the students in Maine, a group of high school students, a high school class, essentially developed this project, got all the permits in place, and raised all the funding so that this project could be built. They called us when the project was just leaving the permitting and design phase, and they wanted someone to manage the construction phase. So it was a couple months that we worked. I think we signed the contract in January of this year, and it was completed within 10 weeks. That's a really quick project cycle for us. We were just involved in the construction phase. These students did a lot to gain community support. They got all the permits, they got the money for the project. It's really an amazing model, and I hope it inspires other people down here to do something similar. Williamstone utilizes a little bit of a larger turbine. It's a 600 kilowatt turbine. It stands on a tower that's a little over 200 feet. The blades are 70 to 75 feet. It powers a stone cutting facility, an industrial stone granite cutting facility. The production from this project offsets a little over $100,000 worth of energy each year. When you account for the depreciation and incentives that were provided this project, the payback is somewhere around the 6-year time frame. And that project that I just talked about was in Massachusetts. And now I'm going to switch over to the characteristics that help support the development projects in each market. And I'm going to go through each one of these characteristics and then kind of highlight where Virginia's at and how it may be able to move forward in regards to these characteristics. So interconnection in Virginia is actually pretty simple. There's a standard interconnection process for on-site wind projects, which makes things a lot easier. So Virginia already has that attribute. It's just one of those things that you need in order to build a project. You need to be able to go to the utility company and communicate with them and have a clearly defined process of how you can put your project online. Virginia has that, which is great. Virginia also has a rec market, although I think it could be restructured in order to capture more value and support more growth for the market. RECs are renewable energy credits or certificates, and it essentially is the value of the attribute that's created from producing green electricity. So if you are an owner of an on-site wind project or a small wind farm, there's two revenue streams if you can utilize these RECs. One is from the sale of physical electrons, or in the case of on-site wind power, energy saved from producing your own power. And then the second revenue stream is the sale of the attributes. Now, usually the sale of the attributes of the REC market is dictated by a renewable portfolio standard, which is called an RPS. And that's some sort of goal set forth by the state that they want to produce X amount of power from renewables by a certain date in the future. In New York, in all of these markets that I have up here, there is a mandatory RPS, meaning that the state mandates a certain percentage of the power come from renewable sources within that state. In Virginia, it's a voluntary market, and it does not mandate, it doesn't actually state that you need to get any renewable energy credits from generation within Virginia. And that's something that really needs to change. If you want to support market development in Virginia, you have to set up an incentive for new production to come online in Virginia. In order for that to happen, I think political views need to change, and or there needs to be some sort of change in leadership here. Net metering is essentially a policy set up for an electricity consumer who also produces their own electricity. And it's designed so that when you are producing electricity and you can't use it, you can gain a value for it. And Virginia has a great net metering policy. And the way it's set up is if you are producing power and not consuming it in a certain month, you can put it on next month's bill as a credit. And it's much better than selling it back to the utility company because getting a credit, you're actually realizing full retail value rates. If you were to sell it back to the utility company, they would give you a fraction of that. You'd get something at the wholesale level or considered avoided cost. Capital incentives really, in my opinion, are what drives a market. Capital incentives are just what it sounds like. It's money provided to a project. And it can go, that money or that grant can be given to a project through various project phases. Oftentimes, certain states just provide capital incentives on the back end of projects, meaning once they're constructed. Massachusetts was very forward-thinking. Back in 2006 and 07, they created a capital incentive structure to buy down feasibility studies and site prospecting studies. And so this allowed companies to, one, learn about what it really means to host a wind turbine. And it also helped the state kind of buy down some of the risk that these people have to take in order to build these projects. The development cycle to get from the feasibility study or the site prospecting study to the design, to the end of design where you can actually obtain construction financing, for these larger projects that's hundreds of thousands of dollars and it's thousands of hours of time. So if there is an incentive structure set up to buy down some of that risk, it really promotes people to move forward with examining these projects. And capital incentives are something that right now Virginia does not have. It did in the past. How you fund the capital incentives is a whole nother conversation, but in order to create capital incentives, you have to find a funding mechanism. Same thing with the RPS as well. And so as Virginia moves forward with supporting wind and renewable energy, they need to be focused on where these funding streams come from. Probably the biggest influence on a market is the electricity prices. High electricity prices makes wind and renewable energy projects competitive. The rates in Virginia are high enough to support on-site wind projects in certain locales. So these are some of the characteristics that help define a state and that the state can influence with, well, they can't really influence the retail electricity market too much, but for the most part, these are characteristics that the state can take control of in order to support a project. As mentioned earlier, you also need local support for projects. And local support is probably more important than any of these attributes. With a certain amount of local support, you can get a project done. And so as Virginia moves forward, there really has to be pockets of progressive thinking, of progressive people and progressive communities that are willing to change some of the mentality that exists around them, some of the people's perceptions of wind around them, and they need to be leaders, and they need to work with somebody who can kind of manage them through the process. And so we really look forward to the opportunity to see Virginia grow and to assist that growth in any way possible. Thank you very much. I hope you got something out of this presentation.
Thank you, Loren. Okay, we'll move right into the next speaker, so we'll have some time at the end, as we suggested initially, for question and answer. All right, Doug and Mary McCallum have owned the same house in Roanoke County for 22 years. They noticed the huge amount of wind at their location as it ripped shingles off the roof every year until it was replaced with a stronger roof. What'd you go with, shale? Slate?
40 years.
They thought a wind turbine would be a great idea. A state rebate program introduced in 2009 and a federal tax credit made that dream available. or made that dream affordable. With help from the Virginia Center for Wind Energy, they successfully installed a 10-kilowatt wind turbine on their property after 2 years of persistence. I say persistence in filing forms, attending zoning meetings, and securing permits. So with that, I think Mary is ready. Thanks, Mary.
Thank you. Good morning. Okay, let's see here. So distributed wind is what Loren was talking about too. Wind on site as opposed to the big utility. And hopefully that's going to be part of the answer to all of our energy problems. Go ahead. There's a picture of our turbine after a storm. And what I've got here is a lot of pictures of construction, so you can see what goes into putting up one of these projects. Benefits to the community. One of my neighbors in particular said, you know, this is really selfish. You're just doing this for yourself. But there really are benefits to the community as well. So some of those benefits could include reduced pollutants from traditional forms of energy, reduced demand on the local electricity grid, increased local energy independence, reduced peak power demands, increased in-state electricity generation, diversified energy supply portfolio, and of course it supports American green jobs. So those things aren't selfish. Okay. If you're trying to determine if your site has wind, one of the very fundamental, easy things to do is to look at the tree growth. And you can see in this picture, you're looking at trees from the side, and then next to the picture, you're looking at the tree looking down on it. And you can see how the branches in a higher category of wind start to grow to one side of the tree. In our yard, we're at about a 2 or a 3. Okay? And then, of course, you can consult wind maps. And there's the wind map for Virginia. And then if you zoom in, the next picture, there's Roanoke. And we're situated, Roanoke, you can see the little square that's Roanoke, and we're situated in that brown and tan area that has the most wind in that corner of Roanoke County. And this is the ordinance. When we went to the local county, they didn't have any ordinance whatsoever, and they said, no, you can't do it. So then we had to start working on the county, and they were just starting to think about having a wind ordinance. So they had a person working on it, and so we approached her, and it was at least a year to get the ordinance on the books. And this is the ordinance they finally came up with, and it's a pretty good one. Up to 1 acre, you can have an 80-foot tower, and if you have over an acre, you can have a 100-foot tower. Unfortunately, towers come in 20-foot increments. So if you have 100, they consider the height to be the tip of the blade. So we wanted to have a 100-foot tower and then to have the turbine on top, which has an 11-foot blade, that would be 111 feet. So they said, well, no, you're going to have a special use permit. So even though there was an ordinance, we still had to have a special use permit, or else we'd have to go down to an 80-foot tower, and then you lose a lot of wind, because the higher you go, the better. And then we had one of the people who gave us an estimate come, and they used this software program, and that's a view of our house, an aerial view, and then what they predicted the power could be from a generator there. And you can see it's 5.2 meters per sec. Yeah, meters per second, right? Yes, okay. Which is about 13 miles per hour. Okay. All right, and then the fun part started when we finally got permission. So here's the hole for the foundation. And some of my neighbors said, oh, well, you're going to interfere with the water supply, you're going to have to do blasting, etc. No. So it's 15.5 by 15.5 by 5.5 feet deep, smaller than most residential swimming pools. And then they had to put in trenches. The whole yard got pretty well dug up. Plastic pipes to protect the wires run from the turbine to the inverter in the shed or garage, and then to the breaker in the house. There's the inverter in the shed. On one side you have the power coming in through the bottom from the turbine, and then the inverter does its magic and sends it out to the house. And then we had to have rebar put in. This is all designed. Berge gives you a set of plans, and you just follow the directions. We had a contractor do it, but it's all there. So you can see there's a whole layer, that's okay, there's a whole layer of rebar on the bottom, and then there's the conduit coming out with a string in it to pull the wires through. And then go ahead, it had to get a second layer of conduit, and you can see it crisscrosses both directions. And there's a picture of the turbine in its crate and the blades and the tails sitting on top of the crate there. That's how it came on the truck. Then a template had to be made to hold the bolts. The bolts go down about 3-4 feet into the rebar there, and so that template had to be the exact right size for the tower legs when the tower gets put on it. So that was like the most critical thing and the most scary thing, is making sure that the bolts were in the right place. There's another picture of the template. And there's the conduit coming up through the PVC pipe next to one of the legs so that the wire can go on up the tower. And here comes the cement. And they did get, it took 7 truckloads, ton, you know, lots of, what was it, 56 cubic yards? Yeah, and there they are smoothing it. And then the tower, that came like a giant erecta set. All those pieces were separate, and they all had to be put together on the ground in the yard. All the bolts on the main legs were tightened down to a certain torque. All the cross bars were left finger tight, because if you tighten everything on the ground and then set it up, it's not going to be straight. It's going to be the way the ground was. So you have to have only the legs tightened. Okay. And there's putting the nacelle on. And we got lots of help from lots of groups. This is the Renewable Energy and Electric Vehicle Association that helped us out, and the Sierra Club helped us out, and the Roanoke Valley Cool Cities Coalition helped us out. We had lots of help, and lots of people talked and wrote letters to the board, and were very supportive. And here comes the crane. And you can see now that the crane boom is being attached to the top of the tower. And we couldn't put the blades on yet because there's no clearance. So the crane had to take it up enough to put on the blades. Okay, and here they are attaching the tail, so they still haven't gotten to the blades yet. Took lots of people to help. It's kind of like a barn raising. Now we're starting to put the blades on. And like Loren mentioned, the blades are like 11 feet long. So the diameter is about 22, 23 feet. And now everything's all put together, so the crane can take it up. And here it is going further up. And you can see on the little boom there, I wanted an anemometer because I wanted to measure the wind as well. And many times the anemometer came very close to the crane and nearly got taken out, but it survived. Yay. You can see how close it got. And there's another shot. All right, so now the tower is totally suspended in the air by the crane. So you can see it's up off the ground, and the people are busy trying to move it over, and there's the bolts sticking out of the slab, and they have to make sure that it fits down on there. Here comes a leg down on the bolts, and it fit. And so then one of their guys had to climb up there and detach the boom. And then 3 of their guys climbed up there and tightened all 500 bolts. And it took them about 3 hours for 3 guys to do that. That's one of them working on it. And yay, it's finished. And that's from Berge, actually. I just thought that was a really good slide. Thank you.
Thank you, Mary. Well, with that, I would ask if you would like to take a moment, if you have questions, and feel free to write them down on the index cards that should have been left with you. And which side will you come down and then pass them over in this direction. We'll have someone come by and collect those. While we're doing that, in order not to waste any time whatsoever, I thought maybe we could introduce a topic that maybe I'd try to frame a little and have our panel talk about it, and then maybe by the time we finish there, we'll have some of the questions have made their way down on the index cards. I thought that you had mentioned, Mary, the special use permit in your case that you had to obtain, and in Virginia, typically if there's an ordinance that allows for a wind turbine, it can specify under what conditions, and if it exists already, then you just adhere to those conditions and you can put your turbine up. And for those of you not so familiar with it, in cases where, as in Mary described, they're actually hoping to have a little higher reach with their tower and a blade tip. In that case, they had to go to the county and say, we want a little more, and here's what it'll look like, and you have to have a special use permit in that case. So that tends to change a little some of the community involvement, and it, I think, changes a few other things. I know that Bob, I believe, had to get a similar type permit. I think his conditions might be a little different the way it worked out, but I thought maybe we could have Mary and Bob talk about a little more detail, getting their special use permit, and then if Loren or Doug has comments, we can build on that.
Well, of course, when you have to get a special use permit, you have to have a sign put in your yard, and so all the neighbors, start getting worried what's going on. So it's a lot more involved, and it has to be put in the newspaper. I think that was $250 and then another $250 to have it advertised. So it was a long, involved process. Do you have something to add? Okay.
Independent of the talk I gave here, I put a unit up at my home in Mount Solon, and it was very easy compared to what Mary went through. This was our house land is zoned exclusive agricultural, so that made it relatively easy. I had to go before the Augusta County Board and get a special use permit, $250, but they decided right there and then to approve that, and that was really all it took. It was very simple. It had to be in support of some agricultural effort, however, because we are zoned exclusive agriculture, and that was a little funny. What did that mean? Well, I'm not a farmer, and so I started asking questions. What if I got a goat? Would that and they said, well, it has to support exclusive agriculture. So I planted 6 peach trees. Okay, and that seemed to meet the objective, but it was very easy.
And the only thing I'd like to add is that, if you are considering going through this process, it's important to realize that higher is better. You want to get as high as possible, because your wind speeds are much greater up there, but not only that, the quality of your wind is much greater. So the higher you go, the more likely the wind is going to be coming from the horizontal direction. If you're close to the ground, there's a lot of friction, so it's very turbulent, meaning you're going to get quick changes in speed and direction from your airflow. So you'll actually, if you could imagine it, you'll see these kind of coils coming off the ground and creating all this turbulence, and your rotor doesn't really know how to respond to it. It provides all these unequal loads, and so your turbine longevity will be very compromised by going lower. You never really want to be below the tree line. I would highly recommend not doing that, unless if you have a huge wide open expanse and you're close to water. It might be a certain consideration, but just realize that the higher the better. And if it's a little bit of a headache to get the additional permit, have your installer get it for you. Lean on them. That's what they're there for.
Yeah, I would add one thing at the end of that line of thinking, and just to say that, you know, as I mentioned at the beginning, we've heard in other sessions people talk about, you know, again, in terms of utility scale, wind, you know, Virginia being a stuck state, and you know, having seen a lot of the effort that Doug and Mary put forward, and people like Mark here in the audience, to, you know, stand up to the occasional myth that opponents might offer, you know, such as, you know, blasting is going to ruin our water supply, and I mean, there are absolute, you know, myths that are put forward, and it's really important for people that are informed, you know, on occasion, whether it's at a public meeting or an op-ed, to address these myths, because if not, they grow and more people buy into it. And in that spirit, you know, I think that while people like Bob and Mary, you know, may likely have done this simply for, you know, to generate for themselves, you know, to the extent that they carry themselves and work with other people in their community to speak on behalf of wind power, you know, small wind, and to bring people to help them, you know, set the tower in place, and, you know, have a potluck while they're doing it, those kind of things. That's invaluable, not only, you know, for their friends and relationships directly in their community, but even in the broader community outside of their corner of the county. Because for the utility scale wind, for instance, you know, if there's been a bad experience at the small scale level, and no community is really built through that, then there's not a base, you know, for it to grow. And so, you know, I think of it sometimes from the perspective of someone who's worked on utility scale, that, you know, it's kind of the camel's nose under the tent with people doing this kind of work in their community. You know, that opens up the possibilities for good relationships to be built to do other things. So, and I just wanted to you know, thank these people for the work they do there. Even though that may not be what they have in mind at all, they're probably just doing it just for their, you know, for home use. But you know, the building of community in that sense is just immensely valuable. Let me take a look at the questions that came up, and let's see. Oh, okay. Yeah, here's a good one. This was directed to Mary, and it says, you know, now that your turbine is up, how have your neighbors responded?
I sent out 6 letters to my immediate neighbors, ones that would see it, and I got 4 positive responses back, and I never heard a word from the other 2. And I think the other 2 are still upset, but they haven't, you know, said anything. And the 4 that were supportive were very supportive. Actually, another neighbor that's further down the road, she wrote me a letter that was kind of, why did you do that? You know, you have people who didn't want it, and so forth and so on. And I wrote her a letter back explaining myself, and she now supports it completely. So that was encouraging. Anything else? Okay.
Okay. I have a question that's directed to Loren. How do I get my co-op started with a community wind project in Botetourt County? The manager said per AEP contract that they're not allowed to own generation equipment. So how can the local community supply wind to them and get started?
So you could have another entity own the actual generation assets and then sell power to your local co-op, and you can come up with an arrangement that makes sense to both parties. And you would want to make sure that there's a lot of dialogue at the onset about just the expectations of a project. But really, I mean, I think you're asking a business structure question, and there's so many different ways to form an ownership structure. You know, I'm trying to think of some other resources that I could point you to help you with that. Essentially, I mean, if you wanted to, you could set up an LLC where community members were the actual owners of this project, and you'd sell members. I mean, there's no shares in an LLC, you're a member, so you'd sell units to various members, and each member would pool together their equity resources, and you basically gather up some money from each member, and the LLC could then work with a local bank and finance the construction of a project, and you'd be using that equity as collateral to gain that long-term financing. You might also, if you form that LLC, you might want to consider bringing in outside investors, having some of your money raised by the local community and having another portion of it raised by outside investors. I don't know how large your community is or how willing people would be to participate in such a structure, but that's one arrangement. Luke, can you remember the name of Luke is a gentleman I work with here. Can you remember the name of that document we always refer people to at the Sullivan County meetings that we have, the document on financing and ownership options? Okay. Yeah. It's pushing the envelope. Yep. And so is that up on the Sullivan County website? Could we give them the Sullivan County website? Okay. Well, I'm going to give you the Sullivan County website, and then eventually we're going to put it on there. So if you do want to check out this resource. Luke, again, do you know what the Sullivan County website is? SASD.org. Okay. Yes, sir.
Real quick on that, just as a follow-up, one of the other challenges with the co-ops is if they're legally not allowed to own generation, they may also not be allowed to purchase electricity from a community-owned system, depending on their contract with AEP. So that potentially could be another hurdle in that scenario.
That's an interesting dilemma to be in. I mean, I think you would want some legal counsel to participate in that discussion. I would really question that. You know, if someone said you can't actually buy generation except from me, I'm sure there's a lot of people that would argue that that's not lawful. But I'm not a lawyer.
Right now, PPAs are not legal for private entities to sell electricity, so it's there's been legislation introduced, but it just hasn't gotten anywhere.
Huh. Well, that makes things very challenging, to be honest. If you can't buy energy or create energy, how do you, I mean, this is just a giant monopoly. I'd scream and yell really loud and hope that someone listens to you, because, I mean, this is not fair. And so I would try to petition that. I mean, organize people to say that we think this is not right, and, you know, make an argument as to how this would benefit the community, and really try to articulate that argument to your greatest ability.
My experience in North Carolina with the co-ops is they could pretty much do anything they wanted to. They are not under this they were not under the purview of the Utilities Commission, so they were not required to you know, do the net metering thing, but they could choose to do it if they wanted to do it. One option might be to ask if you've got a local co-op, and the general managers wield unbelievable power there, but just to go before the board of the co-op and explain what you're doing, and they might very well that might get the job done.
Appreciate that observation from the crowd. It's a good point that Bob makes. I mean, Mark, I think as you probably know, as a co-op member, you are a member, and there certainly is room for bringing together other members within the co-op's jurisdiction to try to bring about change. But I think also as was observed, some of the co-ops rely exclusively on their generation from other entities. Some of them they're just distributing the power. Right. So there's some pretty tight relationships there that have been solidified over the years, and I would suggest that some of these kind of rules, I think they tend to arise and be found in places, in states where things are regulated, essentially in a regulated state. Where they're deregulated, you often have some of these small hidden rules, hidden things that people don't often know about. They may often help to open things up for independent power producers and the like. So on a very big level, the status of whether you're regulated or a deregulated state from the State Corporation Commission can have a lot of effects on down the line.
Sorry, and I mentioned actually forming a petition, and that would go to the SCC. Is that the SEC? Is that the SCC? Yeah, and that's who you would petition. And in New York, I mean, we have seen laws change through petitions, going to a comparable commission. It's the PSC in New York, but laws can change, and that's your route to try to make change happen.
And it also could be, I mean, in this case, it could just be purely a contractual issue. If it's just between the IOU and the co-op, might not be a legal or a policy issue. So check the wire on that.
Yeah. Good discussion. Let's move on to another topic from Mr. Zickefoose. And I have this in quote. This is not my phrase. Your junkyard generator charges a 12-volt system, but most appliances run on 120 volt. What are you running off the 12-volt cell? In case I messed that up.
This is a third world unit. This is not where people have appliances. This would be where people are just trying to run a light, a radio, maybe a tiny TV. This is off-grid stuff completely. It would never be interfaced with the grid, and the idea would be, here comes a person that has a radio or something that can run off 12 volt, or some lights that can run off 12 volt. They would come get the battery, take it to where they have those appliances, and then bring another battery back that would need charging. It would not be ever meant to invert and interface with the grid at all. There's no grid, so where you don't have a grid, you don't have 120 volt appliances or 240 volt appliances.
You're not net metered either then?
Oh, no. This is not. This would never be designed to be interfaced. This is a 700 watt unit. This is a real small amount of output. But my experience is when people have no electricity, a little bit is a miracle to them. So that's what this is for.
And you can get DC appliances.
You can. That's true.
They just cost more. Sorry.
Yeah.
They're using RVs.
Okay, another question. Mrs. McCallum described a large weighted slab foundation. And then this question then seems to be directed toward Loren, but I'm sure Mary might have a comment as well. It says, Loren, are driven tension pile foundations or precast precast slab foundations ever used?
Precast. Yeah, depending on, for a home unit, it's typically, I mean, you're going to pour your foundation, and your actual foundation, the size of it, is going to be dependent upon your soil makeup for the most part. But it's pretty simple. For larger scale turbines, a lot of times you got to find ways to actually drill into rock and actually connect to rock. We have a construction crew that kind of handles all that. And to be honest, I'm a bit naive when it comes to the construction of foundations. And so Bob looks like he wants to answer this question, and probably can do a better job than I can.
I think they usually go with a one-size-fits-all on these units. You get a single slab like that, it's a great monolithic foundation, and probably that slab could be set on top of the ground and would still be heavy enough to counteract any moment that could possibly be generated by that turbine. So I don't think we've gotten very innovative there in terms of foundation design, but you know, it's like Loren says, you don't want to try and go down too deep in places, because then you might hit rock or something. So it's just kind of a compromise to put a single slab up, and that's what I know Rowan always recommends. They give just the drawings for a single monolithic block, and it works well, but it uses a gob of concrete.
Actually, the Berkey directions also came with having three.
Did they set, that's
Yeah, one, yeah. So you have three holes.
Sonotubes probably or something.
Well, 3 holes that you fill with cement, 1 hole for each leg. That was another option.
Okay. For Loren, for the turbine installed at the high school, this person is curious, you know, as to the cost of the turbine and, you know, the fees associated with construction management.
The cost of the whole project is somewhere right around $500,000 for that project, and I meant to say that, but it didn't quite come out. For us to manage the project, we just had kind of a time and materials contract, and we may have put in about 300 hours over the course of 10 weeks. And that was primarily 2 people, one managing the project on site and one managing the project from the office. So we kind of have the person in the office handling a lot of the logistics that the foreman can't handle. You know, the foreman is the one that's on site, and he's just managing everybody on site. So there's somebody in our office that's kind of doing all the behind the scenes work, and then there's someone in the field that's just managing everybody else in the field. And so all that probably cost about $30,000-ish, you know, for our time. Did that answer the question adequately?
I thought so. Okay. It seemed to me, yeah. Okay, we have a few more minutes. Does anyone else, you know, we have time, maybe 1 or 2 more questions. Does anyone have a question? Luke, let me just bring this up to you and go for it.
Hopefully this is just a simple question, but Bob, I was wondering if there's any efforts to train people in Haiti to maintain the wind turbine?
Yes, we're planning on doing that actually. We want to do that because you know, yes. Yeah, that site is going, we were going to do that. We thought we might actually supply them in kits and eventually, and if we could train enough people to do it, that would be part of the, again, the economic development effort here to try and get some mechanical skills going. Yes.
Anyone else? Okay.
Would it be easier to get a grant, say, to buy a bunch of birds?
No grid? I don't know, easier to get a grant maybe. I just think in terms of, it's always bothered me that we have all these wonderful car parts that, once they get about 10, 12 years old, they get smashed. And if we can use them for something, I'd like to do it.
Well, I want to thank the audience and our panel. I think they did a great job, and if you give them one last hand, then we'd appreciate that. Thanks so much. And one thing I just want to mention as a reminder, the last bullet in particular, for those of you who are able to stay around this evening, I think I heard some talk that that cookout would be partially moved inside due to the heat. So it might be a little cooler. But if you're able to stay around, some folks that I know that live right around the corner, Annie and Mac, are going to play a little music, and I think they're going to bring a fiddle player with them, is what I had heard from them. I don't know if they had that listed officially, but I heard they might have a fiddle player out there too who lives up the road in Page County pretty close. So it would be a real treat if you can stick around. I hope you have a great day, and thanks for coming.